I'm audible. Hello. Hello. I could not hear you. Soumya. Could you chat in the chat and confirm whether I'm audible or not? Hello. Soumya, could you confirm whether I'm audible or not in chat if you're not able to, because you're not audible for me now. Fine. Yeah. So we can get started because we got the instruction from the admin teams and we can get started. Confirm whether my screen is visible or not. Can you speak somewhere? Because we can have the interaction. Otherwise, it will be kind of one-way communication. I'll be only speaking. So I can get, if it is possible, you can just, because you are not audible to me. I'm not sure, but you're not audible. Fine. We'll get started with the discussion. No, yeah, it's audible now.
Hello, sir.
Yeah, I think now you're audible.
Is it audible?
Yes, yes, now it's on. Yeah, we'll get started. Yes, it is audible. Hello. Can you hear me? Hello.
Yes, sir.
I think, yeah, we can get started. So I'll
Okay.
introduce about the posts and contents. We'll get started with the things. So, okay,
Sure.
I'm the instructor for this course for the data engineering with the Databricks. So I'll be, from my experience, I've been working as a data engineer from last 9 years, and I've been into the teaching also for 4 years. So total, my experience is around 12 to 13 years now. And yeah, I've been working as a data engineer from last 9 years. I've worked on a different projects. My journey started with working on the traditional Hadoop. Okay, so I mean, in my initial phase of the career as a Hadoop developer, where I actually implemented Hortonworks and Cloud platform, and then I actually moved to the cloud platform like an AWS and Azure and the Databricks. So that's my journey. So before we get started, so what's your objective of learning this course?
Sir, I want to get into a job wherein uh, this is an interesting topic. So I had a break in my career, so I want to
Okay.
restart my career, and this is where I thought I can get into.
Understood. So, in what technology have you worked earlier?
Actually, I have worked 8 years in networking. I worked in Cisco, and
Okay.
throughout my career, it was all about protocol verification and C programming initially into development.
Mhm.
And in verification team, we used to, of course, have scripting and automation a bit, but more into technology of L2 L3 protocols and
Okay,
layer
understood.
7 as well.
Mhm.
So, but I have done few courses in Coursera, some basics of Hadoop and big data, a bit basics I know. So I was
Understood.
trying to understand AWS also. Yeah.
Okay, okay, fine. Yeah, I think there are other candidates also have joined. So, yeah, I'm actually trying to understand what is your background, what is your objective behind learning this, so that we can then align the discussion topics so that it will be helpful for you guys. So that's the main intention because behind, I'm asking this question. So Nirav is
Okay,
there
sir.
also. Yeah, Nirav, could you unmute
Tomorrow
yourself?
also is it 9 o'clock, sir?
Yes, it's the
Tomorrow
same.
also is
Yeah, it's the same every weekend.
9 to 11, is it?
9 to 11, yes. Yeah, hi Nirav. Yeah, could you explain about the objective behind joining this course? So what you're looking for other than this course?
Uh, for actually I am working in TCS, so I
Okay.
was working want a career change. That's all.
Okay, okay, understood. And current technology?
I'm working previously I worked in React, but now
Mm-hmm.
I am in Adobe AEM from manager.
Okay, understood. So you have a little bit of programming and background.
Yes.
Understood. Okay, fine, fine. Yeah. So we'll get started. I'll explain the details, basics of the data engineering. What is data engineering exactly? So I'm considering you guys as are not from, you don't know anything. So I'll start from the scratch and then we will actually try to understand each and every deep concepts as we go ahead. So what is exactly data engineering? Okay, so prerequisite for our course is like these two things. So we have to have the good knowledge of the SQL and the basic knowledge of the Python. So these are the two things we have to have. Okay. So if you have to have the very good understanding of the SQL and the basic of the Python. So what are the kind of things we are going to do with the SQL? Because no, data engineer do most of the their kind of transformation in whatever kind of coding they are do, they actually use mostly SQL language. Okay. Along with that, we require Python also. But Python, you don't have to be kind of expert in those Python. You need a kind of basic things as in the data types. Okay. Then we have kind of flow controls. Then you should understand the basic data structure like list, tuple, set, dictionaries. Okay. And you don't have to be put into the object-oriented programming. Okay, but if it is, if it's good actually if you have some sort of oops concept also. But in real time we don't use the oops and all that for any kind of coding in the data engineering. Mostly we use Python as a scripting language here, or kind of we write the code where we actually use this the basic Python. Okay, so any question into this? So before we actually start other things, so are you comfortable with the SQL and Python?
Yeah.
Okay, fine. So that's the basic, and you have to be good in the very good into the SQL because SQL is a kind of basic or mother language of the data engineering. If you don't know the SQL, you cannot survive as a data engineer. Okay, so it's a simple language. Anyone can learn it, but you have to have a good practice into it. Okay, so that's the main thing. Okay. Next thing is like in what platform we are going to use in this course for the practice purpose and the learning purpose. Okay, so this course is actually built in such a way that you'll be getting the basics of the big data. Along with that, you'll be going to get the kind of good exposure to the Azure Databricks. That's the main thing. So whatever the practice we will be doing, we will be using the Azure kind of Databricks platform. Okay. So as an kind of practice platform. So I'll introduce that. You with this platform also. So that's the main thing. Okay, so that we will be using. So before we actually jump into the our discussion, what is data engineering, what kind of things we will do as a data engineer, where we stand, we should understand a lot of basic things. Okay, so maybe today's class we will not be doing any kind of course or kind of coding exactly, but I'll try to make you comfortable with the basics so that you in the next session onward you will be really comfortable understanding whatever things I'm talking actually. Okay, so let's get started. So uh, as you know, the post name is itself is a big data Hadoop kind of database. All these different names are there. So whenever the big data comes into your mind, what thing comes into your mind? So could you explain anyone for you? What is a big data for you guys?
I think it's a chunk of massive amount of data that I
Mm-hmm.
need to organize in a better way. That
Okay. Any other thoughts? Fine, you're correct. Yeah, you can speak whatever things are in your mind so that it will be kind of interactive. Anyway, I'm going to explain what is exactly big data. Any thoughts? Okay, fine. So big data is exactly it's a problem actually. Okay, so what is big data? So traditionally we were having the single system kind of architecture. Okay, so before 2000 exactly I'll say. Okay, so before 2000 we were having exactly what kind of thing? Kind of single systems. But what is the problem of the single system? Like they cannot scale infinite. They cannot scale as per my requirement. Okay, so scaling is what I'll explain in a while. Okay, so that's a problem with the traditional system. So everything was written in a such a way that it will work on a single system. All the databases, all the kind of operating system, everything is actually built for a single machine. Okay, they never thought like a scale of data will increase in the future like in this way, and we need to scale the things. Okay, so as a solution for that, they have come up with this new architecture called master slave architecture. So that's the base of your modern all these big data technologies like Spark, Hadoop, all the thing of whatever you talk nowadays. It's everything is based on the master slave architecture. Whatever the cloud platform also are there, like all these cloud platform services, they also internally use this kind of architecture, master slave architecture. Okay. So for the Hadoop Spark, the base is actually master slave architecture. I'll explain why we actually come across the master slave architecture. Like a single system you have, right? So your single system, like in your laptop. Okay. So what happened with if you have the older laptop, you come across kind of problem where you see like my laptop is not performing well. So what's the solution for that? As an owner, you think of increasing some sort of RAM or changing the hard disk drive. Okay. So this kind of changes or this kind of scaling, we are scaling from let's say 4 GB RAM to the 16 GB RAM. Okay. So this kind of scaling is called the vertical scaling. Okay. So I'm moving from 4 GB to 16 GB. Okay, provided that your laptop should allow, have as it's compatible for them, you know, extend it can be it can extend the RAM. Okay, but every laptop is not having that kind of facility. But some of the laptop, when you purchase, you have to think about that whether the extra slots are there or not. Okay, so that I can increase my RAM in future. Okay, but this kind of scaling, like moving from 4 GB to 16 GB, is called vertical scaling. Moving from let's say older hard disk drive to SSD. Okay, from older hard disk drive like in 500 GB to let's say 1 TB of SSD. Okay, so this kind of scaling means increasing capacity of your system, single system is called the vertical scaling. Okay, let's say today I have a 16 GB. My hard disk drive is also 1 TB. Okay, but still my processing need increases. So what will happen? You need to again scale, but you cannot scale more because it has a capacity. Your laptop has a capacity. It cannot go infinite. In fact, cannot go increasing all the time. Okay, I cannot go from 16 GB to 32 GB because it's not supporting now. Okay. The similar way, this is what the limitation of vertical scaling. So this has happened in the previous also when the data processing need actually increased in the okay before 2000. Okay, so like in all the databases service like in your Oracle, RDBMS, they were actually installed on running on the single big machine. Okay, these are all the servers actually. Okay, machine servers are same. Okay, your laptop is kind of it is also kind of work as a server, okay? But only the kind of thing is like server has a high RAM and high hard disk drive and higher processing CPUs. Okay, so that's the main difference. So that was the traditional problem that they were not able to scale it, okay, because data processing requirement started growing. So, they scale from, certain limit up to certain limit, but after that, still your data processing need, data storage need increases. The organization, all these old organization used to buy a new servers. Like in the way, whenever your old laptop it cannot be scalable. What you do, you just bring a new latest laptop, which is obviously which is going to have the higher capacity. So similarly, that was the traditional way of doing the, kind of, throwing out the older servers and bringing new server. But that was kind of really, really costly kind of replacement. Okay. So that's the problem with the older traditional databases. Okay. So they were kind of having high cost, high maintenance, in all the things were there. So that's the problem with the traditional servers. Okay, so vertical scaling, that is the problem with the vertical scaling. What is for then we come up with this kind of Hadoop architecture where we actually started putting the things as a master slave architecture. Okay, so where we started, trying to scale the things horizontal. Okay, so I'll explain what is horizontal scaling and all that. So this is what the master slave architecture looks like. Okay, so you don't get into all these names. I'll explain these names as we go ahead. But here you can see that one is master machine, and there are multiple slave machines or worker machines. Okay, you can call it slave or worker. It's the same. So you can see over here, you got a one master machine and the multiple slave machines. Okay, so this is what we call it as a master slave architecture. Okay, these are the machines. Okay, so now together they are actually building one cluster. So when the configuration is like this way. Okay, so my screen is not visible.
Yeah, it is visible. But I think you are in the desktop.
I think, okay, let me stop my shading, reshare again. Okay, I think I lost a few things. Okay. Yeah, actually, I
Yeah,
started with this. I was just speaking about this prerequisite web discuss and then platform web discuss. This Azure, Databricks we are going to use, and I was just explaining this thing. Okay, so yeah, we can continue from here. Now it's visible, right?
yeah, now it is visible.
Fine. So this is how the master slave architecture looks like. But what what the main thing is we have to understand over here is it's kind of these machines. Okay, so these machines are actually creating a cluster. Okay, so collection of machine is actually called the cluster. So you have master machine and the slave machines. Okay, so sometimes slave machines are also called as a node and worker also. So these names are same: slave, worker. Okay, machine is kind of same, and node also sometimes we call them. Okay, so it's the same. It's a kind of hard. It's kind of hardware only. So I'll explain what is that exactly. But this architecture is actually helping us to scale actually. So earlier architecture, like I was explaining about you. So it was kind of having the limitation of vertically scaling. Okay, so that was kind of limitation it was having. So let me explain that over here. Okay. So let's say this is what your machine. Okay, this is what your machine. So what are the things? What are the main resources of your machine? Can you name them? A computer system having some main resources. What are those? Okay. First one is CPU. Right? It got a number of cores. Okay, so quad core, octa core. Let's just start with the quad core. Quad means 4, octa means 8, hexa means 16. Okay. So these are some of the resources. Second main resource is the RAM, primary memory. Okay. This is again an important resource. And finally, it's your hard disk RAM and SSD. either hard disk drive or SSD. Nowadays, we got a SSDs only, but earlier we used to have the hard disk drive. Okay, so RAM comes with some certain limitation. Okay, so normally you got a RAM with a 16 GB. Okay, and then nowadays hard disk drive are in the TVs. Okay, so let's say 1 TB, I'll keep it. Okay. Fine, so this is what the resources of on your computer system. Okay, so these are the resources of your computer system. And these are the always really, really important for us because, these are the main things where the computation happens, data processing happens. Okay, so these are the main three resources and always we have to think about it. And this is really, really important from our learning point of view. We should know that what are the main resources are computer. Okay, because, that's really helping us to understand how the processing, optimizing the performance, how data is actually gets processed. As a data engineer, we have to take care of the optimization also. So whenever we have been given with the task of the data processing, we should know that how much resources are getting consumed and we should minimize the resource consumption. Okay, so what are the resource consumption? Main resources are kind of CPU and the RAM actually. Okay, and this is for the storage purpose. Anyway, we have discussed that in detail. Any doubt into this before we actually jump into our next thing? You can post your question in the chat also. Otherwise, you can ask. No questions,
Oh,
fine.
one thing I want to know. You told me that we have to be mastering SQL, right?
Could you repeat?
You previously you told me we have to master in SQL, right? In data engineering.
SQL, yes.
So there are two, right? MySQL and NoSQL.
Oh, okay. See, SQL means SQL language I'm saying. Okay, so SQL is kind of used by multiple things. Like in your traditional RDBMS is like a SQL Server, your Oracle, Postgre. Okay, but whatever the data warehouse also uses SQL. Okay, so SQL language is used for not only for the traditional databases as well as data warehousing also and data processing also. So what we are going to learn, we are going to learn the how to kind of Spark. Spark is kind of main data transformation engine actually, or we can call it as a framework. So that framework also uses the SQL language. So SQL language is kind of becomes common for our data processing. So now your question is kind of which exactly, like MySQL or Oracle or the kind of So we have to use ANSI SQL actually. So that's the standard for the SQL language. So you just don't try to learn a particular syntax from Oracle or MySQL, but you try to learn the SQL. That is what ANSI standard. Okay, so that's the main thing. Have you understood or should I clear it more?
Yeah, got it.
Okay, so what is the closed language? For the Spark SQL is MySQL. Okay, so if you learn the MySQL, you will not find it's different. Okay, because MySQL uses the ANSI SQL standard. Okay, so every Oracle has their own syntax. Okay, 90 to 95% syntax are same in all these databases and data warehouses, but 5 to 10% syntax may change. Okay, so only that 5 to 10% you have to manage. Otherwise, if you are coming from the Oracle, if you're coming from the MySQL or other if you have learned or something different databases, still that works, but that's not kind of, you have to learn totally different thing over here. SQL is kind of same. Only the 5 to 10% syntax varies, so that you have to adopt. If you learn MySQL, that will be helpful for the Spark because then Spark uses same standard as in MySQL, ANSYS SQL. So that's an it. I think now it's clear, okay?
Yes.
Yeah. So these are the resources. So let me introduce two of the things. So let me show you this diagram. So where I'm actually showing a kind of okay. So these are the kind of resources. So you got a resources like your hard disk drive, CPU, and RAM. Okay. So whenever the data processing happens, with the help of RAM and CPUs, okay, and data stored in the hard disk drive. Okay, this is to be very, very clear. Where we process our data we process our data using two resources, main resources, CPU cores and the RAM. Okay, and where we actually permanently store our data, we actually permanently store our data into hard disk drive or SSDs. Okay, so this is to be very, very, you have to be very, very clear in while learning this Power BI data, where we are actually processing and where we are actually storing the data. Okay, I'll be introducing with you the kind of distributed storage and computing. But before that, we should be clear about that. What are the resources from my system or machine which are helping me to process the things, and what are the resources from my system which are actually helping me to store my data. Okay, so now this is clear. So where we are storing our data permanently and where we are actually processing our data. Okay, so whenever we talk about the data processing, which resources are going to help us? Can you answer now? I'm repeating the question. What resources are helping me to process my data from my computer system? Okay,
CPU.
CPU and RAM, both. Not only CPU, but RAM is also helping to process my data. Okay. Now my question is kind of, you can put your answer in chat also. What is the resource from my computer is actually permanently storing my data permanently, because if, if I turn off my computer also, my data is there. Okay, you know that hard disk drive or SSD. Okay, so these things are really, really important, because as we are going forward, we will be learning about distributed computing and distributed storage. That's the base of our big data Hadoop Spark. If you don't understand what is distributed computing, distributed storage, now it will be hard to learn the advanced concept. Okay, so now it's clear that you may be from the computer background or maybe different background, but these are the basic things we know. All of we know, because our laptop, our mobile phone also having all these kind of resources. Okay, your mobile also comes with the RAM as well as the processor. Okay, so whenever you buy also your mobile, you always try to buy a mobile with the higher RAM, because of that, if I am actually trying to use the multiple apps simultaneously, it is not going to get hang or it will process smoothly. Okay, because that's the intention. Because whenever you require more and more processing, you require a higher RAM and a higher good processor. Okay, higher configured processor. Okay, and the storage is a kind of thing. So storage is kind of just it stores the data permanently. That's the main thing. Okay, so now I'll be talking about the distributed computing and distributed uh, processing. Okay, so this is clear now. Any questions?
Yeah, it is clear. I think your sound is breaking.
So that we will be discussing about the different things. Could you confirm others? I'm clear now. Okay, I think there is some issue. Let me. I'm audible now.
Yes, sir.
Hello.
Yes, sir.
Okay,
You're
fine. So
audible.
yeah,
It was not breaking for us. Your voice is good, but the volume is little low for us.
now it's clear or still? Is it
Yes.
better now,
Yeah,
right?
it is clear.
Okay. What do you think I've explained? Is it clear for the thing? Should I repeat?
No, it
No,
is
sir.
clear.
You can go.
Okay. So now we will be introducing ourselves with the distributed computing and master slave architecture. So let me explain what is master slave architecture. And we have been discuss about the limitation of the vertical scaling also. Okay. So now let's say we are trying to solve the big data problem. So what is big data problem exactly? So we got a huge amount of data. Okay, this is kind of, huge amount of data is there. So we got a TBs of the data. So this is quantity data. Okay. So you got a 100 TB of data, right? So can you process this 100 TB of data with a single machine? Okay, single machine. Okay, this is the machine with the limited
No.
resources. We cannot actually process this 100 TB of data because it got a less capability. Okay, so it got a really low capability to, it cannot process because, that's a limitation because small system cannot process huge amount of data. So what is the solution for that? This is one system. Okay, so either I can have the big high end server, which will be really, really costly. So that's not a solution for me. So that's the kind of vertical scaling. So I can, let's say, as we've discussed, it got a four core kind of things. Okay. So let's say there are a lot of, we have something, and let me type it over here. Okay. So it comes with the CPU and 8 cores. Okay. And then what has happened? We have a kind of, 32 GB of RAM and let's say 2 TB of storage. Okay, so all these are the configuration of this machine. Okay, obviously this machine is not capable of storing, okay, or storing and processing all this data because, it got some limitations. Okay, even we scale also, we cannot match this kind of huge amount of requirement. Okay, so what the solution they have actually come up with, they have come up with a kind of, solution of the master slave architecture. Okay, so let's try to understand what is master slave architecture and how it is actually helping us. Okay, so there will be a bunch of machines. Okay, so one of the machine is called as a master. Okay, so let me draw that. Okay, let's say this is what your master machine, and you got a multiple kind of, slave machines. Worker, slave, node are same. Okay, so all these are nodes: master node, slave node, or worker node. So whenever somebody speak like a machine node or something like this, it's the same. Okay, so let's say these are the 4 nodes and these are connected. How they are connected, I'll explain in a while. Okay. What kind of technology they are actually using. So this is what called the cluster. So entire this 5 machine becomes one cluster. Okay, so this is first one is top one is what is master. This becomes your master. And these are the slaves actually. Or the worker. So hereafter we will call the worker because a worker is more used terminal nowadays. So okay, so worker one. So similarly, you will having a number of workers. This is worker number 2. So these are the 4 workers. So I started with this. So let's say my requirement is today is what? Let's say 10 TB. Okay, kind of 10 or 5 TB. I'll start with 5 TB. Okay. So 5 TB is there, and each worker node is kind of 2 TB storage. So total is actually it's almost 8 TB storage is there. So I can, from the storage point of view, you can understand that this cluster got a how much storage? It got a 8 TB of storage total. Okay, collecting from each node. Okay, so each is having a different configuration. So let's say 2 TB, 2 TB, 2 TB. Okay, so that's how it is. Okay, so total is 8 TB. So I can store my data right over here, right? Okay, so I can store my 5 TB easily because I got a storage of 8 TB. I can easily store my 8 TB of data. Okay, now the processing thing is like, okay, so for the processing, let's say these are the core machines. Okay, they got a what? They got a cores. Okay, so they'll be having their own CPUs with the number of cores. Let's say 8 cores for each machine. So 32 cores for core machine and some RAM is also there. So what kind of RAM is there? Let's say 32 GB of RAM is there, and okay, 32 plus 4, that much 30 plus into 4 actually, that much RAM it has actually. Okay, so So you can think about that, the cluster size actually increased. So let's say tomorrow my processing requirement increases. Okay, so tomorrow from 5 TB, I am actually going for the 10 TB. Now I want to process the data of the 10 TB. Okay, let's say 10 TB I data I want to process. So what is the solution? In that case, we will do the horizontal scaling. What is horizontal scaling? Let me show you that. So increasing the machines. Okay, so increasing the machines one by one. Okay, so this is, let me draw it this way so that it will be more understandable. Okay. So I can tomorrow, whenever my requirement increases, okay, so 10 dB is increased. So I can add new machines, okay, small machines. Okay. So this kind of scaling, now I'm adding the new machines. This kind of scaling is called the horizontal scaling. Okay. And I can actually connect with the my master and I can process the huge amount of data as well as I can store the more amount of data. So this kind of scaling is actually called the horizontal scaling. And nowadays everything is kind of based on this system. Okay. So now you can actually easily scale your cluster with the help of adding just the machines. Okay, new machines. Okay. Now, is it clear this thing horizontal scaling and difference between vertical scaling and horizontal scaling? Is this clear and why we actually doing the horizontal scaling?
Yeah.
Okay. So that's the main thing. So each machine comes with its own resources, and that's how it actually increases the capacity of your cluster. So I have a different diagram that show that. Okay, before that, I'll show that how the cluster looks like. So actually, the cluster looks like this way. Okay, so they are actually in the data centers where they actually these clusters are actually their infra team is actually handling all these clusters. So you can see that these are the machines actually 1, 2, 3, 4. Okay, like there are 12 machines so over here. Okay, you may not be aware of the rack concept, but there are these machines are actually kept inside the rack. I'll show that how the rack looks like. This is kind of a rack can have a number of your machines or the nodes. Okay, so some of these machines will be act as a master, and some of the machines from this rack are actually act as a worker node. Okay, so physically they are look like this. So these are the network switches. Okay, networking devices are there in order to connect them. Okay, so this is how the cluster looks like. Okay. So you can see that cluster. This is how the actually racks look like, and you can see that these are the machines actually, and these are the networking kind of wiring and all that happens. And this image is actually showing like how the entire data center looks like. So you can see that these are the racks, and there are multiple machines in the rack. Okay. So actually the kind of infrastructure is actually looks like. So you can see that another image of the rack. Okay, these are the machines 1, 2, 3, 1, 2, 3, and these are the switches inside your rack, which is actually helping us to connect all these different machines. For the representation purpose, I'm actually showing all this as in this way. Okay, so for the representation purpose, I'm showing like master at the top and the slave machines at the bottom. But on the data center on the racks, they actually six machines from the communication happens there itself. Now the role of master is kind of it's the same the way I'll give the one analogy. Okay, I'll give the one analogy which is actually explains us about what is the master and what is the slave actually or worker. Whenever you do a building construction, you actually hire a contractor. Okay, the contractor actually explains the workers like how to do the work and when to do what kind of things. Okay, so contractor is a master kind of thing, and your workers on your construction sites are the actually doing the actual works. Okay, like and kind of making foundation, doing the kind of RCC work, doing the plaster and kind of all this stuff. Okay, so here also master is actually not doing actual work. It only directs the worker how to do and what to do. Similarly, here also this machine is only it's kind of as the name is itself it's a master, so it only directs the workers what to do, what is your task, what you will be processing, what kind of data you will be storing. Okay, but all the knowledge of all the worker nodes is with the master. Okay, so that's the main thing over here. Any doubt into this? What is master? What's the role of master? What is the role of slave or worker machine?
No, nothing for myself.
Yeah, fine. So that's the main thing. Okay, so now you have understood with the analogy also. And even if I give the same analogy of construction, whenever you want to speed up your construction, what will you do? You will increase the number of workers, right? You want to complete your construction on in a less amount of time. What you do it? You will just increase the number of work. Here also, if you want to do some sort of huge amount of data processing in really quick time, what is the solution over here also? You have to scale. What is scaling? Scaling is nothing but the adding the new worker nodes so that I can more work can be distributed to different workers, and that my task is whatever task I'm going to do will be finished quickly, okay, as early
Uh,
as possible.
just one thing. How many
Mhm.
worker node can be handled by one master node?
So currently, kind of there is no kind of limitation, but whatever the real-time implementation which is done by the Facebook actually, so they have managed up to 4,000 nodes actually. Okay, so that is high capacity, that high level they have actually processed, because all these concepts coming from the big organization like in Google, this Yahoo, Facebook, all these companies having a huge amount of data. Okay, think about they have the really huge amount, and they actually practice all these things. So kind of big data ecosystem they have already implemented. So biggest cluster, is around 4,000 more. So okay, implemented. Okay, successfully. So that's the capacity, but you don't go at kind of that high scale. You go maybe going with 10 node, 20 node, 100 nodes. So not more than 100, because that much huge amount of data is not generated by the organization. This big organization only generates a huge amount of data, like Facebook, kind of all these big organization, kind of Twitter or X, all these organizations have the huge amount of data. They have the biggest cluster and they are implementing. But yeah, the real time example is 4,000. You can go up to 4,000, which is implemented. But kind of taking a theoretical point of view, they can say that like you can scale infinitely, but you may be facing some problem after certain number of scaling. Yeah, so those are the things actually. So real time 4,000 nodes cluster is already there with the present. And nowadays, as we have moved to the cloud, you just ask the cloud provider, like, I need these many number of nodes, so they will configure for us. Okay, so we don't have to worry about this. Earlier, we used to have the kind of this kind of questions like how much worker nodes I'll be requiring, okay, based on my data load and all that. But nowadays, as we have moved to the cloud, everything is on the cloud. We pay as we use actually. So whenever we require data processing really quick, we actually get with we start with a bigger cluster with a high number of worker nodes. Okay, we do the processing, okay, quickly, and we release the resources so that we don't have to charge. You'll not be charged for the rest of the time. Let's say I have used my cluster for, let's say, 1 hour. I'll be charged for the 1 hour. So that's how nowadays it's actually happening. And that's why we are actually migration and all that stuff is happening. Like people are moving from your traditional, whatever the ETL, ELT, or whatever your Hadoop, also traditional Hadoop, to the cloud-based kind of platforms where we have to pay as we use, and it actually reduce the cost and even infrastructure overhead also. Like in managing all this cluster require a lot of people, infrastructure, team, space, even your power consumption and all that. Okay. So every organization is now trying to move towards the cloud so that all these kind of overhead for the organization can be eliminated. So nowadays, cloud is kind of compulsory for as a developer also. So we have to learn a cloud, either one of the cloud like an AWS, Azure, or Google. You have to be good with the one cloud so that every organization has moved. A lot of more organizations have moved already, but some of them are still moving from the traditional ETL, ELT to the modern cloud-based kind of data processing, data storage. Now that's clear, and let's move to the another things and how the cluster looks like. Now I'll explain how the data storage is actually happening and how the data processing actually happens. Okay, so I got some of the things. So over here, now you have understood like what other things are there. So I'll explain few of the things with this diagram actually. I think this is visible, right? Okay. So now the same worker nodes are over here. Okay, so this is what as a developer we actually interact with the clusters, okay? Because we actually ask the cluster to process or store something. First of all, we'll try to understand the data distributed storage, okay? So then we will actually move to the distributed processing, okay? So two things are there, really important. We should understand what is distributed processing and distributed storage. Okay, then and then we can actually understand what is exactly Hadoop, how it actually helping us process huge amount of data, and how we can actually run the actually processing task on the this kind of platform like in Spark. Okay, so let's try to understand what is distributed storage. So what is your thought about distributed storage? So whenever this name comes into your mind, do you have any idea about this? Fine. If you have any thoughts, you can share. Otherwise, I'll explain how it is actually happening.
We'll be using more than one processor so that we get huge data stored.
Okay, fine. Yeah, we have to, yeah. So let me explain this. So distributed storage means which resource should come in my mind. As I've explained about the resources, whenever I talk about the storage, which resource from a computer system should come into my mind? CPU, RAM, or hard disk drive? What is your answer? You can type in chat also.
Can you repeat the question?
So whenever I say distributed storage, which resource from a computer system comes into my mind, or which resource is actually helping to do the distributed storage? CPU, RAM, or hard disk drive, or
Uh,
SSD?
to store the data or to help to store the data?
No, no. Which stores the data? Which resource stores the data?
It will be hard disk or SSD.
Right. Any other answer? Okay, it is actually hard disk drive or SSD. Okay, because that's a permanent storage. So in the distributed storage also, what happened instead of one system, we use the multiple systems to store my data. Okay, so how that helps and what is the benefit of that? That we have to understand. So let's say this is what my a file is there. Okay, so 512 MB of let's say a simple CSV file is there. Okay, you know the CSV, right? Comma separated. Okay, dot CSV. Okay, so this CSV got us some data, employee data, and whose size is like an 512 MB. Okay, currently this file is not stored under my distributed storage. Okay, so this is my cluster, and now I'm going to explain that how distributed storage is actually helping. Okay, so we know that why we actually started using the master slave architecture because of the scaling. Okay, because single system cannot hold huge amount of data as well as it cannot process the huge amount of data. So that we have moved to the master slave architecture, and this master slave architecture actually helping. It's the base of the distributed storage also. So I'm explaining what is distributed storage now. So this is the file, single file, 512 MB of file. And I want to store on the distributed. So we'll try to understand. Okay. So mind is fine. So what the cluster master will do in this case? Okay. So master will say that, okay, you can break your file into the 128 MB block. Okay. So in the chunks. Okay. So my this file is actually broken down into the 4 blocks: B1, B2, B3, B4. Now their obvious question is like, and why 128 MB block? Okay. That I'll explain, because there are some advantages of having the 128 MB block. Okay. Now, whenever I say, okay, I want to store this file, master, we actually communicate with the master saying that, okay, hey master, I want to store my file, this emp.csv file. So master will divide this file into the 4 blocks based on the 120 MB, 128 MB. Let's say file size is kind of, it's different than 512. Okay. So it's just divide the block, your file with the 128 MB blocks, and, it will create a chunks. Here, the 4 chunks, exactly 4 chunks are created. In some cases, there could be some 128 MB chunks, and one of the last chunk could be 120 or less than 128 MB. Okay. So it try to divide your data into 128 MB. I'll explain the exact reason of the why 128 MB. Why not 256? Why not 1 GB also? But whenever you try to store your data on a distributed storage, it's get divided into 120 tables. Now, what is the benefit of this? Okay. So all these blocks are actually getting stored on a different machines. I can see block one is actually residing on worker number one, B2 over here, worker two, B3, B4. Okay. So this is how the data is actually distributed. Okay. But whenever as a user, as a data engineer or database, what you can say, data analyst, as a user, whenever you try to access this, you will see entire file as a single file because internally distributed storage are actually managing, they are actually managed all these things kind of internally with the programmatically so that you will not feel like this data is actually distributed. You will on a screen, you will find it as a single file. Okay. But internally, the framework, distributed storage framework actually divides your data into the four machines over here. This is the example. This is hypothetical example, but actually this file size is actually really, really big, like in 1 TB of file. And in that case, you can imagine like if you divide that one TB file or let's say 100 GB of file by 128 MB blocks. So how many blocks will be there and how complicated that is going to be. Okay, but for the representation purpose, for the simplicity, I'm giving this simple example, but actually the data size is huge and number of blocks will be huge number of blocks. Okay. But here I'm trying to explain like one employee CSV, how that is actually gets stored on a different machines. Okay, here you can see that B1, B2, B3, B4. Okay, that's how it is actually stored. So what is the benefit of this? Okay, so what is the benefit of this? Now I can have the huge amount of storage. Okay. So let's say there are multiple files and I want to store the multiple files also. Wait, as we have seen, like a single machine cannot hold a huge amount of storage. Or you can see that 1 TB, 1 TB, 1 TB. My cluster having here the 5 nodes. So total size is what 5 TB. So I can actually store data up to 5 TB. That's a benefit because all these combined worker machines actually use the more storage. So now you can see that these are the number of blocks B1, B2, B3, B4. So what is the benefit of this? Whenever the data is actually stored on the distributed storage, it actually maintains the copies also. I have not shown those copies. Okay. So whenever you try to store a block, it actually copies the 3 times. Like in this B1 is there. So B1 could be, B1 is actually having the 3 copies. So those 3 copies could be on a different node also. Okay. So the B1 copy could be like, let me try it over here. So B1 have actually maintained 3 copies. Okay, let's say these are the copies and can think of this. Okay. So whenever I store a block, a distributed storage architecture automatically copies it into the three copies. Like the first one is over here, second one is over here. It is on this machine actually. So you can think of it. I'll put it over here. Okay. And this one is also on this machine. So it internally keeps the 3 copies actually. Okay, by default, distributed storage. One of the examples is HDFS, Hadoop Distributed File System. So what is the benefit of that? All these are the machines and machine can fail. The machine can fail, hardware can go down. So there could be some sort of electronic malfunctioning or something, sometimes something can go wrong. Okay, something this node is not, it got some sort of issue. It becomes kind of dead. So whenever one of the machine becomes dead, what is the problem with that? Whatever the data on that machine will be not available. That's why all this distributed storage keeps all these kind of copies. Okay, so here you can see that there is another copy, and you can see that this is another copy. So that whenever this user is want to read this data, it can be served from the other copies. Okay, so that's a kind of benefit of undistributed storage. We call it as an fault tolerance. If the fault happens, it can be tolerated because of the number of copies maintained. Okay, so sometimes you may be getting the question in the interview also. Why the kind of distributed storage are called a fault tolerance? Okay, so how they are actually managing the fault tolerance? So whenever you try to store a particular file, it always makes the 3 copies of that particular block actually. Okay. So B1 is actually 3 times, B2, B3, B4, all the 3 copies are there. I'm not showing those copies over here because the diagram will become really, really complicated. So, but you can imagine that all these blocks having the three copies, then they are residing on the different machines. Okay, they are not residing on the same machine because of the fault tolerance. If the one of the machine goes down, becomes dead, I can get still the things, what you can say, that these data blocks are available and that can be served or that can be used for the reading purposes. Okay, any doubt into this? What is the fault tolerance? Have you understood why distributed computing actually makes the three copies of a data block? You just clarify yourself over here because you are repeating.
Yeah. So to distribute to each other, right?
Yeah, go ahead.
And if I want to access the previous file from somewhere else, so I can easily access, right?
No, I didn't get your question. So previous means,
So I'm saying that if I want to access previous file from some other B1 or B2, so I can easily access it, right?
yeah. So you have a copy. So why we are actually making the copies because of the failure. Okay, so one of the machine can go down. Okay, there is no certainty that all the machines will be alive. Okay, if I don't have these copies, let's say I don't have these copies, and this machine goes down. So what will happen? Your data will be not available, and that's it. You have the kind of businesses where we require data, right? So if the data is not available, everything gets spoiled. Everything will be stopped. So that's why actually this distributed storage actually maintains three copies so that the one of the block is actually corrupted or something is happened on the other machines. Okay, that's why the availability is B3 is also available, but I'm not showing over here because makes the diagram really, really complicated. But you can imagine that. So now if I ask what is a fault tolerance, you can think of fault tolerance means if the fault happens with the one of the worker machine, still the work is not going to get kind of stopped. Still work can be done with the help of other machines. That's the main thing. Okay, now it's clear. Okay. And have you understood how the data all these blocks are distributed? Okay. And why they are distributed? Because we are actually trying to learn the distributed storage now. Okay. We have not yet moved to the distributed computing. So that's the main thing. Any doubt into this?
No, no doubt.
Are you able to relate yourself where we are standing, what we are
Yes.
trying to do? Okay, so as a data processor and data engineer, we do the two main things, data storage and data processing. Right? The first thing is like when data should be stored on the distributed storage because in a single system, I cannot store the huge amount of data that we have discussed. Okay. 100 TB I cannot store on the single system. So that I have, what they have come up with? They have come up with the master slave architecture, where the master slave architecture is actually trying to, it is horizontally scalable so that whenever my data storage requirement increases, I can scale by adding the new machine into my cluster. Okay. How they are actually getting added nowadays? You just have to ask your cloud provider, like today I have 10 machines. I need a 10 machines more. Okay. And then you can request that 10 machines more. Automatically within few minutes, they will provide you the new machines. And that's how you actually scale from the 10 machine to 20 machine. So that sort of scaling is now possible. But earlier we used to have the kind of physical data centers. So where we were actually trying to add the new machines, purchasing new machine and adding the new machine into the cluster. That was kind of kind of complex task that was requiring admin peoples and all different peoples also. So nowadays that is also all that kind of overhead is actually eliminated with the cloud. Okay, so whenever you require more number of machines, you can just ask the cloud provider and you will get all those new machines. I think this is clear, right? Okay, now the next thing is like whatever the this B1, B2, B3, B4 is there, where they are actually getting stored. You can see over here, I'm actually showing them on top of hard disk drive. Okay, these are the permanent thing. Okay. So whenever I write the data on the distributed storage or trying to store the data on the distributed storage, I always use the hard disk drive or SSD because I need to store that data permanently. Have I started to processing data yet? No, I have not started to processing data yet. Okay, for that purpose, we require a distributed processing platform. Okay, frameworks. Okay, so now you must be asking, like, a distributed storage is kind of it's a concept. Okay, but what is exactly tool we are using for this purpose? Okay, so distributed storage is actually used by the Hadoop distributed file system, HDFS. Okay, and all these modern storages, object storage like an S3, ADLS. Okay, these are cloud-based storages. But traditionally, we have used the Hadoop distributed file system. Okay, the name itself it is saying like a Hadoop distributed file system. Okay, so that's why I actually tried to explain what is the distributed storage concept, and these are the examples of the distributed storage like HDFS, S3, ADLS. S3 is from the AWS. ADLS is Azure Data Lake Storage is from the Azure. Google File System is also there. And that these are the famous three, and there are different cloud provider provide the different storages. Okay, so mainly we will think about the HDFS because that's the first kind of a distributed storage. Okay. So all the historical point of view, all this has happened from the Google. Okay. So Google started all these things. They've come up with all this architecture like a master slave architecture, distributed storage, distributed computing. Okay. So traditionally, if you think about that, the first kind of distributed storage like an HDFS, or distributed file system. This is still used, but nowadays people have moved from the HDFS also to the kind of this object storage, which is S3 ADLS. Okay. So their architecture is actually maintained by the all these cloud provider like an AWS and Azure. Now we don't have to think about too much because we store our data over there and we process that data. So while learning all these things, we'll think about how to digital file system so that we can learn the things. Okay, so whatever I'm explaining, this is actually relate to the Hadoop distributed file system, HDFS. Any doubt into this?
No.
Okay, so whatever the data we are storing on the distributed storage, it actually gets permanently stored on the hard disk drive. Okay. Now, what have they have done it actually exactly? How they are actually this layer actually this entire blue box, this entire blue box actually represent the Hadoop distributed file system, because we can see that this is kind of one layer. This is virtual layer actually managed in the programmatically. Okay. So Hadoop distributed file system is actually written in programmatically in the Java language actually. So whenever you store the data, you don't feel like you are storing on the multiple machine. So this virtual layer of the HDFS, it actually shows everything as a single machine. So internally they manages all this, whatever the complexity or programmatically they manage how to read and how to not to read. Okay. So you can think about this layer as an HTTPS. Okay, this is what the distributed storage looks like. Okay, this is a single layer which is actually storing the data on the different machine. But as when we actually try to see on your system, you will not find a kind of any difference how the data is internally stored, because architecture is or master slave architecture is actually looking after all these things, how to store, how to read, all that stuff. Okay, so from the user point of view, as a developer point of view, you will not see all this visually, but until you actually deep dive into this, you will see details of the each and every block and all. You will not find the difference. Okay, so whenever you write the things on the HDFS, you will find it the way you are doing on your normal computer system. But internally, they are actually managing all this master slave architecture, and that's how the data is actually getting stored. Now let's try to understand the next thing is what is a distributed storage. Okay, whenever you store your data, okay, so this process is called the ingestion or data ingestion, we call it. Okay, so whenever you store your data, it needs to be processed. Okay, we don't only store the data, we have to process the data. Okay, so main thing I'll ask you guys, why we are actually storing huge amount of data? What is the main objective of storing all this huge amount of data? Can you answer that? Why we are actually trying to store this huge amount of data?
No idea.
So can you repeat the question, like exact?
Yeah, why we are actually storing huge amount of data on the distributed storage?
Yeah, because the data is drastically growing. As we
Mhm.
know, the population is also growing. So,
Mhm.
huge data, for example, in a bank, the customers, the
Right,
number of customers are growing, or number of people traveling around the world with the flight details.
right, right, right.
Those.
Understood. So yeah, one of the main things is like data is increasing, and we have to store that into the distributed storage. And the second thing is like we want to find the insights from this data, because whenever you store a huge amount of data, the main intention is that finding the insights or the value from that data. In order to find the value from this data, we need to process that data. Okay, so we need to process that data some. Okay, and for the processing, I have as I've explained, for a processing purpose, what resources we require? CPU and RAM. Okay, we require CPU and RAM. Okay, that's the main resources. Okay, so already I've discussed this diagram, so I let me draw this thing. Okay, so now what I'm I'm trying to draw is like a distributed processing. Okay, what is distributed processing exactly look like? Okay, so now this imaginary layer, which is actually and then this kind of pink box, it is actually showing like what it is showing. It's showing like I'll be using all the CPU and RAM from the different purpose to process my underlying data, which I have just stored. Okay, and if I use this kind of CPU RAM for processing my underlying data, which is okay, that is called exactly the distributed processing. Okay, so what is distributed processing exactly? I'm trying to process the things on each different machine. Okay, so whatever the data is on this machine, I can process that in there itself. Okay, so I'll process the data over here. Okay, so similarly, whatever the data B2 block is there, I'll process there itself. So I'll process over here. I'll process over here. Okay, so okay, this is what we call it as a distributed computing and or process. So chunk of data we have stored on a different machine. Okay, a machine having three resources like in storage, hard disk drive, and the CPU and RAM. So what I'll be doing, whatever the data is stored on my particular worker machine, I'll try to process that data on the same machine. Okay. So this is called as the locality reference. So Hadoop or kind of one of these technologies, this master slave architecture, they try to compute the things where they are actually. Okay. So, if I'm trying to move this block to some other machine and then I'm processing, that will be a kind of costly operation because all these are the huge number of data moving across the network is kind of really costly operation. Okay, so always Hadoop architecture or Hadoop framework. Okay, so this Spark also try to process the data locally itself. Okay, it never tries to move the data and process the things. Whatever the data locally available on my machine, worker machine, it tries to process it. Okay, so that's the main thing. And this entire kind of individually computation of this. Okay, so that's why it is called the distributed computing. Okay, my task has been distributed, my data has been distributed earlier, right? Now what I'm trying to do, I'm trying to process the data on a particular machine, and that's becomes a distributed computing or distributed processing. So some of the data will be processed over here, some data will be processed over here, okay, some data will be processed here. This is what the parallel processing also. So we are trying to do the parallel processing also. So parallelly, all these worker machines are working to do the task. Okay, and that's how the parallel processing actually help us to do the task really quickly. So now, have you understood this? Now, what is distributed storage and what is distributed computing? Because this is the basics of whatever we are going to learn. Okay. Now, what is the example of the distributed computing? Spark. So Spark is one of the example of distributed computing. Okay. So this whatever this pink box is actually representing, that is the Spark. Okay, so we are really at the beginning. So we have not yet started or jump into the Spark. We are just trying to understand the basic concept. What is distributed storage and what is Spark? Now you can understand that where we are standing. Okay, so whenever you learn the Spark kind of technology, it's a purely a distributed compute engine. Okay, it just compute the things. It store Spark can store the data? No. Spark only processes the data which is actually resides on some storage. What kind of distributed storage? HDFS, S3, ADLS. There could be, this varies from the organization. Okay. So these are the different examples. HDFS is one example. A particular organization may be having HDFS, a particular organization who is actually having AWS kind of things. They may be having S3 and some organization having the Azure platform. So they may be storing their data into the ADS. Okay. Now you must be able to figure out where we are standing, what is the exactly distributed storage, and where Spark is. So now if I ask a question, what is exactly Spark? Is it distributed storage or distributed computing engine? What is your answer? It's a, you can type in. You can type in the chat also. So it's a distributed processing or distributed, you can call it distributed processing or distributed computing engine. Okay. I'm audible, right? Okay. So that's the thing. So now you're clear. If you have any questions with on this topic, like on distributed storage and distributed computing, you can ask right away. So hereafter we will be jumping into the more detailed concepts. Okay. Now you can see over here also, the configuration of the cluster is actually calculated in such a way that, like, you can see that 5 TB. So whenever we talk about the storage, so we sum all the kind of storage on the individual machine, 1 TB, 1 TB, 1 TB. So it's become 5 TB storage. Processing, so and the RAM. Okay, so 16 GB RAM on each machine, 16 into 5 GB of total RAM, and each CPU having a 4 cores. Means 4 tasks can be done at a time. 4 means what? One of the kind of CPU comes with the cores, means kind of it can handle 4 parallel tasks. Okay, kind of that thing mainly. Okay, so each CPU has a 4 kind of cores. So total number of cores will be 20 cores. Okay, so 20 parallel tasks can be run on this cluster. Okay, so that's how the cluster configuration can be calculated. Okay, master having its own calculation. Master will be coming with the 16 GB RAM, 1 TB. Okay, but whenever we talk about the cluster, so your master and the slave machine makes a cluster, and cluster has its own capacity, like a storage capacity, processing capacity, and how that is calculated. We actually try to add all the storage, add all the RAM, and add all the CPU number cores, and that's how the cluster configuration comes into the picture. Okay, so whenever we actually try to process something, we should know that what kind of cluster size I require, because nowadays as we move to the cloud, we can get the different configurations, and as per my workload, I have to choose a particular cloud configuration. Is it clear? Okay, so fine. So you have understood like what is storage, what is distributed computing, and where we are standing exactly. So this is the basic of our distributed storage as well as processing. Now, what will be main thing we will be learning as a part of distributed storage will be we'll try to learn the HDFS. And as in we are actually going to use the Databricks platform. Databricks having its own file system called Databricks file system, DBFS. Okay, so that's a Databricks file system that we will be using for our storage purpose, and the Spark for the distributed computing. Okay, there are what is there is kind of there could be a question in your mind, like is only the Spark is only the kind of distributed processing platform or framework available in the market. So there are multiple, like Spark is not only, there are multiple distributed computing platforms. Like there could be earlier it was Hadoop, but because Hadoop was kind of having some drawbacks. Now that's why we actually moved from the Hadoop to the Spark. And the competitor for the Sparks are like you can find the Flink is another competitor. Okay, and there are multiple. Okay, so one of the famous is a Flink, but Spark is more famous because of the it has a lot of lot of features that is actually makes Spark unique in the market, and that's why we are actually learning the Spark. Okay, so main thing is that. Okay, fine. So I think we are good with this diagram also. I'll explain one diagram before we actually jump into the other things. Okay, so how the data processing actually happens. Okay, this is triangle actually shows that how the data is actually processed in a particular system or machine. Okay, so for the CPU needs data to process. Okay, so CPU actually looks for the data into the register memory. Okay, so these are the different memories actually exactly in your computer system. Hard disk drive, RAM, cache is kind of small memory, and register is again a smallest memory. Okay, but whenever CPU tries to read the data or process the data, it actually looks into the CPU. Okay, so if the if it, in the register actually register memory, CPU looks into the register memory whether the data is available or not. Then if it is not there, it actually tries to get the data from the cache memory. And if it is not in the cache, it goes to the RAM. And if it is not in the RAM, it goes to the hard disk drive. So this is how the data actually moves. Okay. Okay. So whenever the data requires data processing requirement is there, CPU looks into the first register, then cache, then RAM, and then hard disk drive. If it is not in this first three, it obviously it's going to be there in the hard disk drive, and then the data moves from the hard disk drive to RAM, RAM to cache, and cache to register, and from there the data processing happens. So this is how the data actually moves in your kind of computer system, and that's why we are actually looks for the bigger cache also, because whenever you have the bigger cache, you can actually you can process the things quickly. Now there could be a question like, and why we require the register memory, cache memory? Why cannot directly CPU get the data from RAM and hard disk drive? Okay, because CPU have a different speed of CPU is kind of high processing unit, so the frequency kind of speed that matches with the CPU, that is only can be matched with the register and the cache memory. Okay, kind of in order to process the data, we cannot directly connect to the hard disk drive, because the hard disk drive is a slow memory kind of, it cannot give the data quickly as required by the CPU. So it actually, that's why this registry and cache memory is there, get the data quickly and process it as soon as possible. So that's the basics here from the computer background. So you must be all these things. So CPU, these registers, cache, RAM, and hard disk drive. Okay, let me now explain the few things so we can come to know that we are what we are actually trying to do, where we are actually standing. Any doubt before this? I'll be introducing one concept called data pipeline now. Okay, fine. Let's try to understand. The main thing we are actually trying to do with the data engineering or processing huge amount of data is to find the insights or find the value out of this data. Okay, but this is not that easy. Like we'll get the data, we'll find the insights, and we are done. Okay, in the real-time projects, we have to do a lot of things in order to in order to get the insights of the data. Generating some reports. Okay, most of the time you will be generate finally some report dashboards. Okay, using Power BI kind of tools. Whenever the data is there, you will find some insights. Okay, and then from that insights, you will create a one final report. And that report is actually it is a final outcome of your data processing. Okay, so this is what I'm just showing some of the one example over here. Okay, so most of the time we actually fetch the data from the external system. Okay, what are the external system? Like let's say some RDBMS system like a MySQL, Oracle, SQL Server, or Query servers. So here I have given one example where we are actually fetching the data from the MySQL. Okay. Okay, why we need to fetch the data? Because we are actually dealing with the historical data. We are actually processing historical data, not the current data. Okay. Before I explain this thing, let me explain a few basic concepts so that you'll understand more. We'll jump into the data pipeline once we understand some basic concepts. First of all, we'll try to understand what is OLAP and OLTP. Okay, any idea? OLAP, OLTP? Have you studied OLAP, OLTP? You must have studied. Okay, so if you have not studied, I'll explain. OLAP is what? An online analytical processing. Okay, and OLTP is what? A transactional processing, online transaction processing. Okay, so these are the broad concepts. Okay, these are not the tools exactly, but these are the concepts where we are, your systems are get categorized based on their use cases. Okay. OLTP is kind of a traditional RDBMS. Although your traditional RDBMS like Oracle, Postgre, SQL Server, okay, MySQL, these are comes under the OLTP system. So OLTP systems are kind of the systems which are built for write many times and read many times. Okay, so you can write the data many times and read many times. That's the main purpose of the thing. Okay, and these systems are actually used in your all this kind of operational system. Okay, these are also called as operational database or operational systems. Like whenever you go to your bank, okay, so you some withdraw some money or you deposit some money kind of things you do. But as soon as you deposit and withdraw, you will get the SMS saying like, okay, this much amount has been reduced and this much is remaining. The behind the scene, all this actually happening on your OLTP system like an Oracle. Okay, so one of the example of the OLTP system is Oracle. So all these things are happening around the Oracle. Okay, so I'm giving the one example like an Oracle, but it could be some other database also. But that's why, because it actually built for the online or transactional purpose. Transactional means real-time data against the multiple writes and multiple reads are happening over there. Okay, these kind of OLTP system are generally normalized. Okay, so normalization is one of the kind of way to minimize your storage spaces actually, so you can reduce the storage. So these are the kind of OLTP systems are generally normalized, whereas OLTP systems are denormalized. Means we don't care about about the storing the data optimally. Okay, so if there are duplicates in the data, that is also good. That is also valid for us, because we think about the data processing, mainly data processing and the time required for the data processing. So we don't care about the storage over here in the OLTP system. What is the example of the OLTP system? All these modern data warehouses, and Hive, Snowflake, Redshift, all these are the OLTP systems. Okay, and what are the examples of the OLTP system? These are the traditional RDBMS. So what we are learning now, it's OLTP systems. Okay, so we are doing the analysis. So whatever the Spark, whatever the Hadoop is actually processing the historical data or doing the analysis. Okay? So whenever we actually say something like what is exactly all these OLTP systems are there and how they are actually doing. So OLTP systems are actually gather the historical data, all your past 10 year, 20 year data, and then we process the data. So if somebody asks what is the main difference of OLTP, you can write, you can say that it's a kind of OLTP systems are write many times and read many times. But whereas OLTP system, write once and read many times. Yes, we write once in a while, okay, like a monthly once we write the data, and then we are actually processing that data. But here in the OLTP system, every second, every minute we write the data, as well as you update the data and you read the data. That's the main difference. Okay. So we are actually dealing with the OLTP systems. We do the analysis, Spark, like distributed storage, distributed processing. These are concepts are actually comes under the OLTP, because we have to do the analysis on the huge amount of data. So that's the main thing. This thing we have discussed already, but vertical scaling and horizontal scaling. And whatever the things we will be dealing, we are doing, it's a horizontal scaling, because this one is got a kind of limitation. Okay, I'll explain this final slide. Okay, so these are the different roles in the kind of in a particular organization. So what data engineer do, data analyst and data scientist do. There could be kind of question in our mind. What is exactly the role of all these people, all these professions? The first is data engineer. So data engineer actually build the data pipeline. What is data pipeline? Means moving data from the source to the destination. Okay. So as we know that water moves from the source to destination. Similarly, data engineer also moves your data from source to destination. Okay. It during that moving the data from source to destination, a lot of things a data engineer need to do. It need to process the data and all that stuff. Okay, what are the basic technology stack a data engineer requires? They have to be good in the SQL, Python, and one of the cloud technology. Okay, and the distributed computing concept. Okay, that is I'm actually explaining now. And next thing is data analyst. They are actually do the analysis work. Okay, so they mostly they deal with the customers actually, or kind of end users. Okay, so they must be very good with the SQL, reporting platform, Python. R language is not that compulsory, but if R language is also they are compatible, they can actually learn. Okay, but mainly the SQL, BI tools, and the Python. And the data scientist is kind of a bit different. Okay, they actually they are good with the mathematics, statistics, and they actually build the models, machine learning models, and all that. They have to be very good with the kind of Python, R language. Actually, mostly they use the R language for the doing the data scientist work. But they should have the basic knowledge of this kind of basic to intermediate knowledge of the SQL and the Python. Okay, these are the different professions. Okay. So you should know that sometimes data engineer do the work of data scientist and data analyst also, but that's depend on the organization. Sometimes they ask to do end-to-end things. Sometimes you just just build the pipeline. Okay, that's depend on the organization, which company you are actually working, what kind of project is there, based on that. Okay, so these are the basic concepts. So I think you're good with this, are we?
Yeah.
If you need out, you can just ask. Okay, now I'll explain what is a data pipeline and what we are actually trying to do. Okay, so with this example, I'll explain. Okay, so data pipeline is imaginary pipeline. So it doesn't mean that we exactly create some sort of pipeline, but it's kind of imaginary pipeline we create. That's why we call it as a data pipeline. Okay, so what is the main work of a data engineer? Moving data from the source to destination. That's the main work. Okay, sometimes that is also called as a ETL or ELT. Okay, so traditionally, okay, so we were doing the ETL, but nowadays we do the ELT. Okay, so we first extract, load, and then transform. Earlier we were having the systems; those were doing the ETL, like an extract, transform, and load. Okay, so what is the example for the Informatica? The best example for that. But now those systems are kind of having a lot of different issues, the drawbacks. So that's why we have to move to the big data or Spark kind of things where we actually first we'll do the extract and load, and then we will process the data. Okay. So let's see, you can say this is the MySQL, and let's say there are, or you can say there's some one table, big table, I want to copy that into this. Okay. So this operation, copy this data into this is what your cluster. Okay. So this blue box is what your distributed storage. I can call it as an distributed storage. I already written over there. Okay. So you can see that this is what the distributed storage is. This is what the distributed storage. Is it visible, right? Let me increase the font a little bit. Okay. I think now it's visible. So this is what HDFS, so auto digital file system. Okay. Now, whenever you move the data from the outer system, that process is called the ingestion. Normally, we call it ingestion, but in the form of ELT, we call it as an extract load. Okay, so this is what the extract and load. We'll be getting the data from the outer system to our system, like an HDFS distributed storage. Okay. So now you may be asking, like, who is doing this extract and load or ingestion? Okay, so for ingestion, we got a dedicated tools. We are not going to use the Spark for that. For ingestion purpose, we use the kind of different tools from the different platforms. Okay, so like in kind of, if you think about the Azure, they use just the ADF, Azure Data Factory for the data ingestion. So data ingestion is kind of not that difficult task, but it's one of the important tasks in your data pipeline. Okay, the data engineer do data ingestion also and data transformation also. Okay, let's say this is what the CSV file, employee CSV file, and I want to find how many employees are there from a particular department. That's my task. Okay, so this is what the analysis work I've been given. So bring the data from the MySQL and process that data. Store first of all, store that data. Then you process that data and give me the insights. What is the insights from that data? Employee data. I want the count of employees from a particular department. Okay, let's say there are some department, IT, finance, then you got a HR. Okay, so these are the some departments. So you have to find how many employees are there in a particular department. That's the task I've been given. So first of all, what I'll do, I get this data from the MySQL. Okay, so MySQL is having, let's say, 1 or 2 years of the employee data. I'll get that data into my distributed storage HDFS. Okay, for that purpose, I'll be using some ingestion tool. Let's say in my case, Azure Data Factory. Okay, I have used Azure Data Factory. So I've given that this is what the ingestion process, and you have a different options. Okay, so from Azure, you have a ADF, Azure Data Factory. From AWS, you can use this tool, AWS Glue. From GCP, you have a data flow. Okay, so each and every cloud provider, they have created their own kind of, what I can say, ingestion tools for doing this task. So the obvious question is like, as a data engineer, you come across in your mind is like, how many tools I need to learn? Okay, so you have to, first of all, you have to stick with the one cloud. Okay, let's say you decided that I want to learn the AWS. Then you have to learn about all the tools from the AWS. Whenever you think about the Azure Database, in that case, you have to think about the like an ADF kind of tools. Okay, so that's how you have to decide which tool I'm going to learn. Okay, as in a course, in this course, I'll be explaining about the Databricks. Okay, and okay, so here we are not going to discuss about mainly about the data ingestion, in detail, but we'll try to do some of the things on the ADF. Okay, so we'll stick our discussion to the Azure Databricks so that we think like in one cloud as in Azure currently. We don't, trying to move across different cloud because then it will become really, really complex to learn each and every cloud services. Okay, so that's the main thing. So now you have what I'm trying to explain is how the data pipeline looks like. Okay, so this data ingestion happens. That process is called the extract and load. Now this data is over here. Mostly, whenever we write the data, we use the Parquet file format. Okay, so this is one of the optimized file format. Okay, so normally whenever you deal with the big data ecosystem having their own file format. So we will not using the traditional file format like a CSV, like other file format like an Excel. All these file formats are not going to be used in the whenever we actually process the using of data. So one of the best file format is the Parquet file format. We have a separate in detail discussion about the file format that I'll be doing. Okay. So any doubt into this extract and load? Fine. Next thing is like once you extract and load, we actually do the transformation. This is what employed out, file is there. Okay. So I actually ingested this data, okay, and into the Parquet file format. I'll explain why we have used the Parquet file format because it's optimal file format. It has a lot of benefits. All those benefits I'll be explaining in detail. Okay. So just think about that. We are using this file format to store our data on HDFS because it has a lot of benefits. Next thing is like once you do the load the data over here, next thing is we have to transform that data. Okay. The transformation happened in the 3 layers. Okay. So nowadays this architecture is called the medallion architecture. So bronze, silver, and gold. Okay, so whenever you bring your data, you just bring the data as it is. Then you clean that data. Okay, what is the cleansing activity? So whenever you get the data on your distributed storage, we have to standardize this data. Okay, sometimes column names are not correctly written, or I want my column name to be named in certain way, so I can rename that. Okay, if the date format is in the different date format, I want the date format in particular my way, I'll change that date format. Okay. So there could be some extra columns I need to add into my data that I can add it like when this data got ingested. Okay. When I want to process what kind of, if it something like the date of birth is given of a particular employee and I want to find the current age. So I can add a formula and I can create a new column as an age. Okay. So these sort of columns are called the derived column. Okay. So this kind of activity we do it, from, whenever we do the clean the data and finally, like in whatever the task or business logic you have been asked, we apply those business logic. Like in here, in this example, I want to find number of employees of a particular department. So finally, I'll write some SQL code or, PySpark code that will process this data. And finally, I'll get the output as a number of employees belongs to particular all the departments. So that's how the data movements happen. Okay, so raw data means as it is, whatever the data we get it, then we actually clean that data. That clean data is called the clean data, or sometimes it's called silver data. And finally, we actually build presentation data or kind of gold data, which is actually consumed by the reporting platform. Okay, so here I'm showing Power BI dashboards and all that. Okay, and this data can be utilized by the not only by the reporting platform, but it can be utilized by the AI machine learning team. Okay, so that's the main thing actually. Any doubt into this? How the data movements happen and what is the exactly role of the data engineer? I think we are clear over here.
Sir, what is Parquet file format?
Parquet file format
Like,
is a kind of here I'll not discussing because that's a separate topic, but I'll explain like it's a columnar file format which is actually helps us to kind of store the data in with a lot of benefits actually. Okay, I cannot store the data in the CSV file format. That file format is called the flat files. Okay, those file format are the traditional file format, but they actually require a lot of space. Okay, let's say 100 GB of data I want to store. Okay, from MySQL to over here. So whenever I store the Parquet file format, okay, so it will be reduced to the 20 to 30 GB only. Okay, so 70 to 80% size reduction is actually happen with the help of Parquet file format. Okay, so that's the main
so,
benefit of.
so the ingestion function with the tools, whatever we're using, ADF or
Mhm.
AWS,
Mhm.
so that is converting the flat
Yeah,
files to Parquet.
yeah. Whenever we do try to write the data into the distributed storage like an HTTPS or S3 or ADLS, we have to explicitly mention that how I want to write my data. You can mention Parquet file format. In some cases, some people may be need the data as it is in the CSV file format also. They can keep in the CSV file format. So explicitly, we have to say that I want to write my data with the Parquet file format because it has a lot of benefits. Those benefits we will be
Perfect.
discussing in detail. Exactly, we have to even discuss about the columnar file format and the row-based file format in detail. What is the kind of CSV? We got a CSV, XML, JSON. All these are the different file format. But why we are actually moving towards this optimized file format, and what is the benefit of that? And whenever you actually try to read data from this Parquet file format, it's really quick because of the lot of features. Those features I'll be explaining what is the metadata, pull down predicates and all that. We will be having separate discussion on. Okay. Now you have understood this pipeline. Okay, so end to end, what is the data engineer do? Okay, so this is what the imaginary pipeline happens over here. And you can think of this is what the source. Okay, so this is what the source. And this is the entire pipeline is actually becomes a data pipeline. Okay. So you can think of this as in a pipeline. You can think it gives the visualization of the pipe. Data moves from here, okay, and come out over here. Okay, so this is a source for me. This one is a source, and these are the destination for me, or sing or target. Okay, so these are the same word. Sing, target, destination are the same word. So as a data engineer, we do the ingestion, transformation. That's it. Okay, so both two things we do: the ingestion, transformation. That is ELT, extract, load, and transform. We do. But a lot of things we do inside that. It's just not like that simple. The way I've just said, like just do ingestion and the transformation. But a lot of internally, a lot of things we do. Okay. Now I've shown the two layers, like in this blue box I've shown as an Hadoop distributed file system. On top of that, I've shown like this. This is what Spark. Whenever data is there, movement from the raw to from bronze to silver, silver to gold is actually all this data processing is done by the Spark plugin. Okay, so Spark is actually helping us to do all the processing, data movement. Okay, raw to clean data and clean to presentation list. Okay, so this naming convention varies from the organization. Some organizations say, some companies say raw data, clean data, presentation data, or final data. Okay, nowadays that is Medallion architectures are actually more famous with the Azure Databricks or Databricks. They will got like in bronze, silver, and gold. So whenever they say the bronze means raw data, as it is data which is actually ingested from the external system. There is no change. But from the bronze to silver is the movement of the data, okay, data transformation. That transformation, once you move the data from the bronze to silver, that is a clean data. And what you can say, the additional things are added over there. But okay, so that's the thing. And finally, we move the data from the silver to gold, okay, saying that this is my final data, and now you can consume that data. Okay, so different teams will ask different data, and different tables will be there in the gold layer, in the final layer that can be consumed by those teams actually. Okay, so that's how it is actually. So any doubt into this? What is data pipeline? What is the role of Spark? What is the role of distributed storage like an HDFS? And what is the end user for us? What is the source? Okay, this is one of the example I've given MySQL, but there could be some external sources like a file server, okay, where we'll be given some CSV, JSON data also, and then that will we can consume that data and we can process that data. Are we good till this? Okay, fine. Let me skip your things. So now we'll try to understand the Hadoop distributed file system is actually exactly, so that you can understand the basics of the Hadoop and the traditional how we actually come across the Spark and all that. The old kind of historical thing a little bit, and then once we actually understand your HDFS, you will be understanding okay, so what exactly HDFS works, how the distributed file system works. Let me open the lights. I'll explain about the basics or details of the Hadoop distributed file system. So we have already discussed about what is distributed storage. And one of the example of the distributed storage or one of the tool implementation or exact implementation of the distributed storage is HDFS, which is coming from the Hadoop background. Okay. And HDFS is a file system. Okay. So file system, as we know that we have some file system on your computer system. If you know detail about what kind of file systems are there. Okay. So Windows actually use the FAT, NTFS, okay, this kind of file system. Whereas the Linux uses the ext3, ext4 kind of file system, okay, file storage, okay, file system. So this is really, really important. This is actually built for storing the huge amount of data exactly. Okay. So that's the main intention, and it is coming from the traditional Hadoop. That's why it is called the Hadoop distributed file system. So you can see that Hadoop is a kind of base layer of any architecture. This is the difference, and I'll explain this difference also. So we started with the Hadoop 1 earlier, okay? So and then we actually moved to the Hadoop 2, and then after that, actually we started implementing the now using the Spark more and more. Okay. Now also Hadoop is there, but that's actually used very rarely because Spark has actually gained lot of market actually. So if you think about the traditional point of view, so Hadoop 1 was like this. So HDFS is there, storage layer was HDFS, but processing layer was MapReduce. Okay. So distributed storage was there, but for a distributed processing, it was using MapReduce. Okay. So MapReduce kind of it was having some drawbacks. It was not that kind of it was not able to process the things in memory actually. So that's why it is actually but kind of it's actually removed by the Spark, or Spark is more favored than the MapReduce. That was a problem. But this is the initial phase of the Hadoop. Then actually they come up with the Hadoop 2.0, where they have introduced the YARN. So YARN is one of the important things, which is actually cluster manager. Okay. So we know that what is cluster and resources. Okay, so you are aware now what is the cluster and what is resources. So cluster got a resources like master slaves are the different machines over there, and each machine having their resources like in CPU, RAM, and the hard disk drive. Okay, so YARN is actually managing the two resources mainly CPU and the RAM. Okay, so that's the main purpose of the YARN. And YARN actually allows us to use the different processing engines actually. Okay, so earlier we were having the MapReduce. Okay, but with the help of YARN, I can use the data processing framework like a Spark, Flink. All those can be can be usable. Okay, so that's a framework but one kind of say features they have actually given with the help of our 2.0. And then people started using Spark instead of MapReduce because of the earlier it was not possible because earlier it was kind of tightly coupled kind of thing. So HDFS and MapReduce was the kind of default option. You cannot replace that MapReduce with any other things, but with the help of YARN, this layer. So YARN becomes a kind of operating system. So you can install kind of whatever the processing framework as you required and you can work. So that's the benefit of YARN. We will be learning YARN bit. Okay, so YARN is actually main thing in Spark also. So YARN actually helps us to manage the resources. Okay. So what about the resource negotiation? Because on the cluster we will be doing a lot of tasks. Okay. Who is helping us to get the resources, manage the resources? The YARN is actually intermediate layer that is actually helping us to manage our underlying resources on the cluster. Okay, there are three things actually. One is a processing framework that is like a Spark. Then we have a cluster manager, then the storage. So currently, I have introduced you with the distributed storage like HDFS and the distributed processing Spark. But I have not yet introduced you with YARN actually, but because that's a middle layer between the processing and the storage. We will emphasize on the YARN as we come across it. Now let's try to understand what is HDFS and how the HDFS architecture is looks like. Okay, some of the things I have already explained. Okay, so HDFS architecture it's again a master slave architecture. There is one master and there are one number of worker nodes or slave nodes. Okay, so the HDFS architecture having their own naming convention. So for their master, okay, master node is called the name and the slave nodes are called the data nodes. Okay, so that's a naming convention. Each and every master slave architecture having their own naming convention. Okay, Spark is having their own naming convention. Here, HDFS is also having their own different naming convention. So hereafter, whenever if I talk about the HDFS from the HDFS point of view, the master is what? Okay, it's a name node, and your slaves are the data nodes. Because the data nodes are actually storing actual data. That's why it is called the data nodes, and the name node is actually only includes the meta information. Okay, meta information means just kind of information like a file name, which block is stored on which node, all this information is actually stored on the name. So this is the architecture. So how whenever you try to store a particular file, a name node keeps all the meta information. Let's say I've given one example like a 512 MB file, employee file we have stored over there. So what kind of information a kind of name node is actually keeps? It keeps the information like an okay. So I've discussed about the three copies will be there. Okay, so block one will stored on which nodes actually. Okay, node one, node two, node three. Okay, so based on all this meta information, so internally it is actually stored. Okay, that is managed by the your name, and that's how whenever you try to write the operations, you come to know that where is my file, what is the location, how many blocks are there. Everything is actually managed by the name. It's a meta information. Okay. So in the meta information, what kind of different meta information is actually stores? Okay. Hierarchy it stores, with direct dictionary names it stores, file names. Okay. The way we operate on our Windows system, we have a folder, subfolder, and the file. Similarly, HDFS also keeps the data in similar fashion. Dictionaries, okay, there could be sub dictionaries. Okay, so some parent dictionaries, child dictionaries, all the all the all the hierarchy, all the directory names are actually the track of all these dictionaries are kept by the name. Okay. Then the file name, obviously, and the permission, ownership, access control list, means who is having the access of the watch file. If there are multiple users on your HDFS, in that case, which user having which files access and all that information. Okay, block size, as we discussed, block size. Okay, replication level. Replication means how many replicas are there. So normally it is 3 replicas. We can keep the 3 copies, but it can be configured. You can go for the 4 copies, 5 copies, depending upon the how critical your data is actually. Okay, so that you will not lose data in case of any kind of failure, user code and all that. Okay, so all this information is actually kept by the name node. Okay, so these are the meta information. And where is the actual data resides? Actual data resides on the data node. So that's how the HDFS architecture looks like. And that's how we are actually storing our data into the HDFS. So we'll be discussing in detail how the read and write operation actually happens in HDFS, so that you will get a more idea that how internally how the distributed file system works. But whatever we have discussed till time, any doubt into this? So already we have passed to the 11:03. So we'll try to wrap up before, if you have any questions, I'll take those questions and we can wrap up all the 2 days. I can review the things of what we have seen today. So before we actually close our session today. Any doubt? We're just starting with the HDFS architecture. Tomorrow into our session, we'll deep dive into this in detail.
Sir, what is this metadata what we store? What that block is called?
This is master actually. This one is master. Okay. So this master is actually keeps the meta information. Let's say I have a file, right? I want to store that file. Okay. So I got one example over here. Okay. Let me explain that even. So see over here, I want to store this file. It got a 4 blocks. Okay. So whenever this is you, okay, as an data engineer, you want to store this file into the distributed storage HDFS. Okay. So whenever you actually store this file, external file to HDFS, first of all, you actually communicate with the master, saying that okay, I want to store this file on a HDFS. So master will come to know that okay, somebody is requesting write operation. So it will check whether these nodes are available or not. Storage capacity available or not. Based on this, it will decide that where I want to keep the data. Okay, so this master node decided that okay, the block 1 of this file I'll keep it on the worker 1. Block 2 over here, block 3 block. This is how who decides? Master decides. Okay, and then this copy happens to all these worker nodes. Okay, but this information where block has been kept. Okay, this is the meta information. So B1 is kept on the W1, B2, W2, B3, W3, B4, kind of this. Okay, and even it doesn't no, keep the first copy, second copy, third copy also it keeps. Okay, so I'm not shown here because on all the copies, 3 copies are maintained for each block, but that increases the complexity. That's why I'm actually keeping the only one. I'm showing the 1 copy, and I've given the one for the B1. I've given the example of 3 copies actually. So all the copy information, all the information actually stored in the master, and all the location and all. This is what the meta information would be. So exactly this is what a meta information is. Is it clear now, or should I explain it differently?
Yes, sir, it's perfect. Yeah.
I think so it's just meta. This is all the meta information. Okay, information about the file or where it is stored. This is what the basic thing, but along with that, a lot of things are here. Directory is there, permissions are there, the block size is there, replication is there, access. And the last location, well modified, what is a particular user may be given 10 GB of 20 GB of space. That is what the quota for that user. They cannot move out of that quota also. Okay. So only that kind of a lot of things are there. Those things are actually kept in the your name node as a meta information. Other doubt? Any other doubt? So you don't have any doubts, so we can wrap up for
So,
today. Yeah, go ahead.
sir, it will always be in the master system, right? So, what if we lose this data?
Also, so I'm not explaining about that because nowadays we have moved to the cloud, so we don't discuss about this too much because it's automatically managed and developer don't worry about this nowadays. But still, from a historical point of view, I explained. Okay, so always you got a two nodes, okay, name nodes, primary name node and secondary name. Okay, so secondary name node is always synced with the primary name node, and if something goes wrong with the primary, secondary is always there. Okay, and if one as soon as first is goes down, secondary becomes automatically what you can say the active, and then it will serve all the required requests. Okay, meanwhile you have to again you have to fix this which the node the primary node which has failed. Okay, and that becomes the then secondary calling. So always you have two nodes always there are helping you to get the data on the right.
Perfect, sir. Thank you.
Yeah. Any other doubts? Any other general queries like from it could be kind of your expectation from the course. So you can explain me. So you can think of that and we can proceed back. Any feedback from the session also. So if you're looking for something else and what you're expecting, so that I can improvise in the next session.
Next session will be tomorrow, 9 to 11.
9 to 11, yes, exactly. Fine, I think we are good. So if you don't have any questions, we can wrap up for today and we'll see you tomorrow at the same time, 9. Okay. And you can keep your questions noted so that you can ask me after the sessions. I'll be open to take your questions after the session. And in the sessions, I can take this questions from the relevant topic. Okay. But if there are some other questions which are related to topic or maybe your different questions, I can take that after the session also. I think thanks for the session. Yeah, we can actually.
You will get this recorded session also, right?
Yeah, we will get the recorded session. Yes. Yeah, fine. We can wrap up over here. Yes, see you tomorrow.
Thank you, sir. Thank
Yeah,
you for your
thanks.
time.
Yes. Bye bye.